On the bench today is the EconoPET. This is a Commodore PET replacement PCB by Daniel Lehenbauer and his son Milo. It's designed to replace the main PCB inside a Commodore PET, or it can operate in standalone using a USB keyboard and HDMI output. It's an open hardware project that at the time I'm making this video can be built for around $150 in parts. I'll put a link to the project page and the GitHub page in the description below. At power on, you're presented with a menu of different PET configurations, 40/80 columns, 50/60 hertz, early or later ROMs. The EconoPET is based on the Universal Dynamic board. It has 96K of RAM, which 64K is bank switched the same way the 8096 PET is. Standard PET I/O ports, 50/60 hertz, 40/80 columns, 9 or 12-inch screens, graphic or business keyboard, US keyboards only for now, but it's still in active development, and even has programmable CRTC when you're using a 12-inch screen. It has a built-in speaker and an audio output jack, USB port for using a standard USB PC keyboard, and HDMI out for standalone use. One of the limitations is that it's not compatible with standard PET expansion devices, such as devices that connect to the socket like RAM-ROM replacement boards, Super PETs, devices like that, because the CPU operates at 3.3 volts instead of 5 volts. There's a dividing line on the board here. It's labeled right here. It's kind of small, but this is the 5 volt side. This is the 3.3 volt side, including the CPU and the expansion bus. When you're using a 9-inch screen, the CRTC registers are read-only to protect the screen. US-only keyboards at the moment, and the ROMs have been patched to fix bugs, but also mostly to allow the use of different hardware combinations, like using a 9-inch monitor with 80 columns and that sort of thing. The SD card contains the PET ROMs and configuration files. You can load any ROMs you might want to, including custom character ROMs. It won't function as a disk drive, but you can load programs from it. More on that later. The USB-C port cannot be used to power the device. It's only for USB keyboards and for reflashing the bootloader. It's powered by 9 volts DC. Power can be applied by this barrel jack here. There's also a 9-volt pin header here, or the standard PET power connector. Note that on the PET power connector, this pin here is a 9-volt output. This pin is the input. All of the connectors have pin headers next to them in case you need to extend the signals for some reason. There's a standard PET IEEE port and a PET user port for user port devices like modems or game controllers. Now the PET doesn't have power on its user port, but this feature was added. There's a jumper here that allows you to switch pin 2 from the normal video output to plus 5 volts, which is a very nice feature. By providing 5 volts on the user port, just like the Commodore 64, you can use Commodore 64 cartridges like Wi-Fi modems or game controllers. The 2 cassette ports A and B can be swapped by changing these jumpers here on the bottom. That will allow you to install this inside an original chiclet PET that has the internal cassette drive. The configuration switches here allow you to select the monitor size and the keyboard type, dedicated buttons for reset, NMI, and run. The run button resets all the hardware and returns you to the power on menu. The menu button here functions as a reset for whichever PET mode you're in on a short press, and a long press will return you to the power on menu. The JTAG and MCU ports here are used for development and debugging. This flash button is only used when you need to reflash the bootloader firmware. The PMOD ports here are for potential future expansion. And there's an expansion bus connector here, but reminder, this is 3.3 volts, not 5. And of course, the standard PET keyboard and video outputs. There are some additional keyboard pins here for potential future expansion. Here's what's on the SD card. You have your bootloader and your firmware files, and the FPGA folder is, I assume, FPGA code. There's a configuration file that defines the ROMs to load from the ROMs folder. This contains all the ROMs that you might want to use. And then in the config file is where you define the menu item that shows up on the power on menu, the ROM that you want to load, at which address you want to load it. README file shows the changelog for the most recent firmware update. HDMI output now supports limited CRTC emulation. You can optionally specify a default config to load in the configuration file to load when powered on. And the ColorPET preview, which gives you color output over HDMI based on Steve Gray's ColorPET project. Color buffer starts at 8800. And then there's this high-speed virtual data set. And we'll take a look at the PRGs folder and the README file in here. Load file name. If a matching file name .prg file is found on the SD card, it will be loaded. And if no match is found, it'll go back to load from a real cassette tape. Okay, I have the EconoPET set up on the bench with a USB keyboard and a USB-C adapter. I've got my video recorder connected up to HDMI and passed through to the monitor. My bench power supply is dialed in to 9 volts. And we'll turn it on. The power light red here in the corner comes on immediately as long as there's power. The green status light here flashes while the bootloader is loading and goes off when the bootloader is finished. And the done light illuminates steady when the system's finished starting up. And if we select a PET to run, find ourselves in Commodore Basic. Pressing the menu button briefly will reset the PET. And holding it for a second will bring up the power on menu. I've got a data set connected to port A. And I have a tape I want to try to load some programs from. I see there's a light here on the cassette port that illuminates when the motor's on. Well, this gauge on the power supply is probably not very well calibrated, but it looks like it's using about 250 milliamps. When I engage the motor on the cassette drive, that goes up a bit. Okay, let's try to load something from tape. I see this game was made during the Cold War. I also added a program to the SD card. Let's see if that loads. Got to specify the name. And that loaded very quickly. The No Pets Allowed demo makes heavy use of the CRTC, which seems to be working. With the disk drive connected now, see how that works. Oh, this doesn't seem to be working quite correctly. I wonder if I just have it on the wrong version of the PET operating system. I swapped out the real disk drive for an SD card reader because I want to be sure that any problems I might run into are not related to the disk. And I want to try Petsky Robots because this is the SNES adapter that comes with Petsky Robots. And it's designed to take 5 volts from the user port, but the PET doesn't have 5 volts on the user port. So this jumper is included for you to be able to remove it and supply 5 volts on the center pin yourself. I have another one that I have modified to take 5 volts from a USB charger. First, I'll move this jumper from video to 5 volts. Plug in the SNES controller and see if that works. Let's use a 60 Hz 40 column. Have the disk image ready to go. So far, so good. Controls, SNES, start game. That seems to work just fine. I wanted to try connecting the Petunia, see about playing some music. Audio output here to this speaker, and this one has the composite video output, so we'll be recording the analog output. Now I've got my stupid Petrix cartridge plugged in to try out the Wi-Fi modem. That seems to work just fine. I don't have any EconoPET software, but let's play around with the EconoPET. It looks like color RAM starts at hex 8800, which is 34816. Four, 8. And that's quite colorful. I feel like I should at least do a basic comparison with another PET replacement board, the MiniPET 4080. This was also designed to be mounted inside the PET to replace the main board. This was created by Tine Mouse Software and sold by the Future Was 8-bit. It is, however, no longer available. And unlike the EconoPET, this was not open hardware, this was proprietary. It has a lot of the same features, all the standard PET ports, keyboard, monitor, 9 volts, menu switch, reset switch. It does not have HDMI out, it has composite output. And the ROMs are hard-coded, selectable with the dip switches here. The SD card slot is actually a full-fledged disk emulator, the SD to PET, which is also available separately from the Future Was 8-bit. And one final thing before I go, I just received my Bling board external Commodore 64 keyboard from Jim Drew's Indiegogo campaign. And you'll be pleased to know that it works just fine with the EconoPET.